I'm just going to show you 3 quick questions under this heading, which is the last of my explanation, sort of, depending on how well or badly you go on this test this afternoon. Based on a question I got asked just as people were running out of the class yesterday. Okay, so when it says problems starting with derivatives, it's usually questions to do with integrate this, or evaluate that, or solve this, and they say by differentiating this, right? Or they say differentiate some random thing, and hence work this out, which is some weird problem, which is like, what does that have to do with engineering? Okay, so for instance, they say differentiate. Now I think the question I got was x e to the x, and I could do that, but I'm going to do x sine x, just because it's under the heading of tree. Differentiate x sine x, and hence find the integral of, I think it's x cos x. Yeah, the integral of x cos x. Okay, and you can see there's some kind of relationship here. The question is just, well, how do you get there? Okay, so this is a product. Let's differentiate it. What do I do? Well, first, do I need to write my u and my v, or do you guys reckon you can do it without that? Just do it without. We're hardcore. I have a friend, and the easiest way to get him to do something is to say, "I bet you can't," and then he'll be like, "I sure can." All right, so v u dash, right, which is sine x. There's my v, and my u dash is just 1, so I'm just going to leave it off. Plus uv dash, so x, and here's where the cos x comes in. Okay, so remember our question was, what's the integral of, well, I'll just chuck it up here. What's the integral of x cos x? Okay, so how am I going to get it from what I've got? Well, you can see I've got 3 terms here, and just like we say with implicit differentiation, you differentiate everything with respect to x. So this is the reverse process. I'm going to integrate every single term with respect to x. Okay. Now whatever this is the derivative of x sine x. So when I integrate it, I'm going to go back, right? So I guess I'll have x sine x, and because I integrated and it's indefinite, okay, I'm going to have my constant flying around there as well. So I've integrated the left-hand side. Now, what happens on the right-hand side? I'm just going to do it longhand so you see exactly what I'm doing. I'll integrate this term, and then I'll integrate this term. Okay, so you can see what I'm after is this last term in the equation. So that's what I'm going to make the subject. Okay, but before I do that, let's just evaluate the integral of sine x. Where does sine x come from? It comes from negative cos, right? Good. So minus cos. Now, this is slightly naughty, but I think you'll get away with it. Really, because I'm integrating, I should have a constant here, right? However, I've already got a constant, and a constant minus another constant is still just another constant. If you want to be really, really technically correct, well, number one, we should have said that c is a constant, so should have said that, okay? But then here, because it's another constant, I'm going to sort of combine it with the other one. If you want to be really technical, you can just make it a different constant, okay? Where d is also a constant, just a different one, okay? Alright, so there's negative cos. I've taken care of the constant, and now there's my integral, the one I'm actually after, okay? So you can see all I need to do now is just make it the subject. So chuck it on the left. Ta-da!